And then many months later, I get this letter with love from Russia and a lot of stamps on it, and I have the product.
Wow. Yeah. Yeah.
Why are we connecting physical things to digital things?
Well, in general, you see, I believe that all of the processes we have in the physical world, they're greatly facilitated when we move them to the digital space, right? We have databases, we have tokenization, we have everything right now on the digital. A lot of things that differ physical and digital worlds, and the main problem is how we connect them reliably. Let's just consider very simple example. Everything started with trying to trace humans, right? For example, fingerprints. And all of these fingerprints, they were put on a database. And they can easily track us. Why? Because every person has a unique fingerprint. That's a very nice connection between physical person and its registry. And it's kind of like a physical NFT, right? And this is a very reliable bridge. And when it comes to trying to connect physical and physical products with a digital representations, we may fail because they don't have this fingerprints.
Yeah, humans have a built-in UUID that they carry
Yeah,
24/7 and can be tested, can't be removed or modified,
exactly.
except under extreme circumstances.
Yeah.
And yeah, you've got a similar thing here, which we can talk about. We do see a lot of different supply chain use cases that are moving in a similar direction to the way that we can identify humans, physically identify. For something physical, the first step is you need to identify it, and you need to know who owns it, or you need to know that it's authentic, or something like that. You need to be able to connect it to a brand. Usually, the brand that created it is the canonical way. So the issuer of the product attaches a brand. I've worked on this at R&E. This is for luxury goods, and we want to bring the definition of luxury down and down to include more things. Now, at the very bottom level, there's another really interesting use case, which is UPC codes. There's a UPC code on there 2 years ago. The new version of barcodes, and the new version uses two-dimensional codes, QR codes, and they embed the same information as this, but you can actually include a serial number, expiration date, web link. All this stuff can be encoded all at the product level for every product, and they can be unique.
And about GS1 standards and the things what they're trying to build in Europe with this digital product passport. It's something that moves very slowly because I saw your video like 3 or 4 years ago. You were talking about the DPP that coming to textiles in 2025. Right now they're postponing this to 2027. Right.
The same things for pharma supply chain has the same problem. Pharma supply chain also has the CSA. Very similar thing as the digital product passport.
Yeah, exactly. And if we're talking, for example, in Russia, it's already implemented for a lot of products, a lot of niches and verticals. It's implemented in a very centralized way. So there is a company who controls issuance of every two-dimensional code. It's not a QR code, something similar, but there's a great need in this kind of control of supply chains and attaching physical products, the digital representations, and it's clear not only by some country, but it's done worldwide. That's cool.
I love it, and I love the Russia approach. As long as Russia's not doing any worldwide commerce, that is the best system. That is the way to do it. If you have a good, a benevolent dictator who handles this properly, then you've got a perfect system. Of course, there is no benevolent dictator for Earth. I love how you brought in Russia's approach to this too, and China's working the same way.
Yeah, I guess so. Yeah.
So, what's your background in? I saw physics.
Yeah. So actually, like the product that I'm working with right now, it has very deep grounds with my experience in physics. My specialization is nanophotonics and optics. In this field, there's a very interesting term. It's called physical unclonable functions, This is purely scientific term. It existed, let's say, for 20 years. And it's the observation that if we can produce systems reliably, if we produce them randomly, then this kind of a natural physical randomness can give us a way for unique identification of objects. If I look at a piece of paper, right, all of them, they're identical to me, right? But on the microscopic level, every piece of paper, it has unique texture, right? And there are actually works that say that, well, look, we can kind of use this texture for unique identification of documents, right? That's really cool on a surface level, right? When you kind of understand that everything you do, like if you look at your desk right now, I understand you're standing, but for example, I'm sitting. My desk is a mess, right? And I would never be able to reproduce this mess for millions of times. So at this specific moment, my desk is unique, and I can take a picture and I can uniquely identify this specific moment, of course. Connecting this broad description to the specifics of my product and just to give a bit more understanding of how this works, I really like to show a very simple analogy. Like imagine that you have a pinch of sand in your hand, you throw it on the table. As a result, you get this random pattern of units of sand. And if you do the same thing millions of times, of course, you will not be able to recreate yourself. And each of these patterns is kind of a physical fingerprint that you can use for identifying objects. And then we, of course, try to understand the limitations of this approach. Of course, with the sand, it's not really stable, right? Something happens and the pattern changes, right? So I need to somehow be able to fix this. And also, from another perspective, if the units of sand are quite large, somebody will be able to replicate this by using some alternative fabrication process, right? By manually distributing all of the units of sand into desired pattern. We try to create very small nanoscale patterns that would be very, very difficult to reproduce in a controllable way. In this work, in our university, we use laser fabrication of random patterns of silicon nanoparticles in order to produce these very, very, very small. We have the substrate, which is just a piece of glass, and on top of this piece of glass, we get the molten droplets of silicon.
Perfect.
We are able to create these clusters consisting of these silicon nanoparticles, and using dark field microscopy, we can see this and use as a fingerprint.
Let me put a thesis out there. In life, everything is physically unclonable.
Of course.
So, however, you need to have a reading process that it has enough resolution. So, for example, hard disks are designed in such a way that we can write the maximum amount of data. What is the primitives that we have for reading versus writing the data that allows us to confidently do this? And then, of course, we want to talk about cost too.
Yeah, of course. So in general, right, when it comes, as you perfectly said, everything is physically unique. In general, if you try to create something in a very stable way, right, if you want to write data intentionally, this physical uniqueness will be on a much smaller scale, right, of what you are able to read. You will still be able to read this, but with some, as you mentioned, like microscopy techniques, scanning electron microscopy. In our case, since we're specifically trying to create something unique, we intentionally use the process that gives us something random, right? In this case, it's just, like throwing a pinch of sand. And of course, there is a certain, also as you correctly mentioned, there's a certain kind of a range of scale how we can do this, right? In this specific implementation, the size of this whole pattern, unique pattern, is less than the width of your hair. It's very, very small, right? In order to read this, you need to have very strong microscopy. It's very difficult to read, but it comes with a great, great copy resistance. I can swear to God, I will not be able to reproduce this exact pattern, right? Well, within some time frame, because right now there are no techniques that will be able to produce this specific pattern intentionally.
So the question is, if your ability to read something matches your ability to write it, then forgery is possible.
Yeah, and the idea is that in general, the forgery is possible everywhere except nanoscale, because the current microscopy techniques, they're much more stronger than the techniques for precisely manipulating matter on the nanoscale. That's kind of a physical limitation that we have. This specific implementation that I show in, it's kind of this very, very clone resistant, very strong, but it comes with a price that we need to have a very strong microscopy techniques in order to read this. And then we can scale up everything in order to be able to read this easily, but this will come with a price that there is a potential for forgers to be able to copy this. And we're basically having this compromise readout, ease of readout versus clone resistance. And we still can work, we can live with this compromise based on the fact, which is another perspective. The price that we need to spend on creating something random is much lower than the price we need to spend to recreating this intentionally.
QR codes, easy to write, easy to read, forgeable, clonable. Now, this is actually not a problem. Actually, I used to work in optics too. I worked on photo receivers.
Oh, they're great.
Great. For government projects for a telecom. So from a laser over an optical cable, or for other open air lasers.
Mm-hmm. Oh yeah.
So the photo receivers for that. Discovery Semiconductors in New Jersey. So if we just compare the ability to read and to write, this actually solves a lot of problems with what you're saying, because if the price to create is low on a unit basis, and if you're etching it, then you can just etch as many as you want, break them apart, and sell them. But if you're doing it for a supply chain use case, like complicated supply chains like pharma and Airbus, or any integrated manufacturing and integrated multinational manufacturing situation, you can actually use this as a secondary. So what you can do is you can buy these, and you can just buy the cheapest ones, and you can just take a handful of them and just drop them somewhere and glue them on. And you'll never need them until you need them. So when you do need them, when the plane falls out of the sky, you're like, was this authentic? We thought this came from Germany. You know, the serial number matches. Like, engineering just uses serial numbers. So we've got an engineering log, we've got a batch number, we've got a serial number. That's what they're trying to even do now. They can barely do that. But when the plane falls out of the sky and the government comes and the news comes, it's time to pull out the scanning electron microscope and say, is this fraudulent or not? And that's a great time to say, actually, this dust right here doesn't match what we had on record. Yes, we're sorry the plane fell out of the sky, but now we know that it's somebody's fault in Germany. And you can just blame somebody else. And of course, they do use this in industrial applications. And of course, they don't need to scan them at the retail level.
Yeah, totally different. And the problem with what I've shown is, the problem of distribution, right? You need to see this kind of somebody who really struggles with this, and you need to persuade them to buy a laser, to buy very specialized optics, to teach them how to use this, right? That's a lot of, that's a nightmare, right? So
I don't think so. Depending on who your customers. Think of pharma supply chain. What happens when somebody dies or multiple people die? Investigators come, government comes, you're fined, throw away things, reverse logistics, bad press.
Yeah,
right?
Sure.
So that cost, I think you're going to have a great job selling this in New Jersey for pharma companies. There's an absurd amount of fraudulent products. Things you're taking, these drugs might be fake. The problem is when somebody does die, you need to know, was it fake or not? And the solution today with the pharma industry, well, let me ask you, case study, pretend you're pharma.
Okay.
Do you know what drugs cost?
Well, of course.
Very big. Once in a while, somebody dies. Okay?
Yeah.
You have to do a whole supply chain study when this happens. I got to figure out why.
Of course.
That takes years. And also know that a double-digit number of the drugs are fake on the shelf today. You find the box. This is the box. What are you going to do if you find out it's fake?
Yeah, I would probably say that it's not my fault that somebody died because of it, because it's not my drug. It's somebody faked it, and we need to find who faked it, not blame us.
Not exactly. So there's a variable here that kind of changes the math, and that is the number of drugs that are fake. There are so many drugs that are fake. When you start telling people this is fake, that is fake, that was fake too, what's going to happen is the news is going to report, wait a minute, a lot of these drugs are fake. So they don't want the public to know how much fake drugs there are, unless they can be confident that only the fake ones are bad. And also, pharma is so complicated. They make it just as complicated as possible to avoid all the taxes. Because if it were less complicated, the laws would be written to tax them. So they make it just a little more complicated than that. Right. So the weird thing about this is it's very hard to motivate them to do something easy to check for fraud. It's got to be correct. They got to be really confident before they start pointing fingers.
In a sense, it doesn't prevent you from a plane falling down from the sky or some person dying, but it helps you to investigate what happened. And then, of course, you can scale everything up and you try to create this system that would be as transparent as possible. So everybody could check this at any point of time with a certain level of trust, which would be fine enough for some specific applications, right? And then at this point, of course, I would like to point out to the specific labels that I sent you, which is another implementation of what I've described.
So we've got some dots in different sizes. Handwritten note, very nice. And okay, so here are the dots. Here's a single unit on a message. So you've got a postcard, and then we've got the dot. This is the size of my thumb exactly. It's branded. I mean, it's cute ways you can brand them differently. On this version, I'm seeing black dots on an orange background. You know, looking at it, there's a glossy layer over it, so I can't really feel any bumps. I can see that each one of the dots is the same size. They're scattered across, and it is impossible for me to tell whether this is printed at 300 dpi or if it was actually using a unclonable physical function. Now, on the second page, I have individual dots like this, which is a great sample. Thank you. I guess I'll look at this one. So sample 1, sample W1. That's got in different sizes. And if I hold them back to back, I can confirm that they do appear different. And I can casually confirm that they do appear distinct. But that's as much as I can do with the naked eye.
Yeah. So in general, the idea is that how we create these labels, right? It's basically a printed design, and on top of this, you have a polish with mixed glitter particles inside.
The polish has it. You're not doing 3 levels. Got it.
No. It's print and cover with polish, and inside the polish, you have randomly dispersed particles. When we print this, we cannot recreate this. You can use it as a fingerprint, right? You can write this into a database. You can, of course, uniquely identify this product. As you very nicely pointed out that, for example, for black dots, you cannot tell if these black dots are really just printed digitally, or if they are like 3D dots, if there's glitter or not. Right. So the idea is that if you use these shiny glitter particles, holographic glitter particles, this is something that cannot be recreated by typical digital printing. So you have a system when you create it, it creates randomly. You cannot control the creation. So it basically takes the best from unique scattering of particles and holograms, which is with holograms you cannot easily copy them. You need specific, Yeah, that's the product, I guess.
So let's talk about how they get the product in their hands.
Yeah.
When you sell a sheet like this, I noticed that they're not numbered individually. And do you sell the sheet with identification?
The project that we currently did, it was with a winery, right? So the idea was to take a batch of bottles of wine. It was like 2,500 bottles, and uniquely identify them. Initially, each bottle, it's like the same. Well, I mean, for the producer, for manufacturer, it's just a batch. They don't think of them as unique numbers. So what we did, we just sent them a stack of these labels, right, and told them to put this to stick it to the bottles of wine. This kind of a unique assignment, it was random, right? We don't care which bottle gets what number. But in general, of course, how you can do this for some other applications, when you print labels, you have also some unique identification. And depending on the application, you can combine this with a QR code, for example. You can combine this with a barcode. And this will be kind of another version, which will be easy to scan with standard scanning devices, and will be additionally very easy to check that it's really authentic. Because the problem that I see currently with this 2D codes, barcodes, QR codes, whatever, is that they uniquely identify, but you trust that each one of them was created only once, right? And there are, for example, even in Russia, as I mentioned, we have this system with digital product passports that is centralized, but it doesn't protect you from somebody who will just get the information about the codes and print these codes, unique codes,
Again,
on fake bottles,
yeah.
right? It's something that's currently like the problem.
There is a solution to that. I have to defend
Yeah.
the NFT approach.
Yeah, I understand.
So the easy solution is if you have custody managed throughout the supply chain.
Yeah.
So if you have a unique number generated by an authority, an NFT, for whatever product, and you have it at the time that it's originally created. So if you have the thing and then you manage the change of custody of the thing, the original sale, or if you send it to a warehouse, distributor, retail, and then to the consumer, then you cannot clone that because the thing that you are not cloning is the NFT in a registry. It is hackable, but it requires the cooperation of the person who's involved in the transaction. Is if the retailer at the store fakes their own product.
Yeah.
So they'd have to have a fake drink, which is fine, and then they would just make a fake label, that's fine, with the exact serial number that they bought. And now this one, with the same serial number, it's unsellable because the regulator already knows that it's been dispensed, or the blockchain, or however it's done. So we've studied this many times for NFTs, and the end result, when I ask anybody this story, I say, what is this in my hand? And they say, that's fake, because it can't be verified. So the end result is we're going to Aristotelian level metaphysics here, but the thing that you sold is the real one, and the other one is the fake one.
Yeah, totally agree with you. But right now, the problem is that since we have different identification systems in different countries, you have still the problem that this one that is kind of not fake but real, you can sell it not in Russia, but in some other place, who will identify it as real because, well, it's real, right? You can check, for example, if the luxury bag is real by just sitting in the lab for 24 hours and checking all of the stitches and whatever. That's the first thing. And another thing that I'm recently became aware of is that typically, if we're talking about the production of fakes, one can say that fakes, well, most of them are produced at the same factory as the original ones, right? People who distribute fakes or specifically somehow participate in this distribution, they're really connected to the people who distribute real ones.
There are two bags created to the same specifications at the same place, going through the same supply chain. The one of them was sold as real and the other one wasn't. And that's solved. In terms of your Russia system, we have to recall Anshikin's law that your ownership of an asset that is covered by an NFT is only as good as your trust in the custodian. So what this means is, as soon as this asset leaves Russia, now ideally, this goes to the end consumer because it doesn't go back into the supply chain. And the end consumer is not generally in the business of buying a bunch of things and mixing them up and selling them possibly as fakes. That's very rare. So that's not a use case that we optimize for. But if it's leaving Russia and it's going to France and they have a separate digital passport, obviously that connection point is where the fraud could happen. But even so, if you have a concrete one-to-one connection between the Russia system and digital product passport, it's still the same thing. I'm arguing it doesn't matter if it's real or fake.
Yeah, I see your point, and that's how typically it's handled right now. But the question is, maybe there's a better way, right? Maybe there's a technology that would allow you to be as sure as you are right now about like the authenticity and everything, and still be much more secure, right? And so you wouldn't need to explain it a lot for a number of times, so for like 10 minutes to cope with all of the possibilities of how somebody can change something, blah blah blah, right? What if you could have a system that would be as secure in the physical world as NFTs are in digital world?
Love it.
Right? That's kind of the position. Because I watched a lot of like your videos and how you say that QR code is an NFT, and yeah, of course, I agree with you. Yeah, right. It's uniquely identifies, but I'm just feeling some that there's something off in terms of like natural coherency between technology such as QR codes and technologies such as NFTs. Because, well, in digital world, we have these algorithms, right, that allow you to create something truly unique, right? And with the QR codes, it's not truly unique in the sense that I can myself print a bunch of the same QR codes. It just doesn't match from the just, let's say, very philosophical point of view. And then I'm come with these like examples of sand that's randomly created, and I try to claim that this idea, this technology, it's much more naturally coherent with the idea of NFTs, because it's something that's uniquely produced in the physical world with the algorithms, which are just the nature of physics, the nature of randomness. You can calculate it like the number of possible positions of these dots. They kind of exceed the number of atoms in the universe, right? So it's
depending on the resolution of the scanning. Depending on how you scan it.
Yeah, of course, but still, you can binarize this. You can, it's combinatorics basically, right? And basically, it's similar to creating a hash, right? When you create this random pattern in the physical world, it's similar to creating a hash in the digital world, right? Or just random codes. And another thing that I really love to point out about how we actually manage to create random things in the digital space, how we generate random codes, it actually comes from physical randomness. There is much more deeper level of connection here, right? And random number generators, physical random number generators, they are work on the same.
Yeah, exactly. And then this is going to be, I think you're going to have a target market of the more important things. I don't know if they're expensive.
Well, yeah.
Critical safety or something, but it's going to be the more important things.
Yeah. Mid-priced products.
I mean, I'd like to get it lower. Sure. I mean, obviously, reduce the definition of luxury. We want everything to be luxury.
Yeah.
Maybe this isn't luxury, but alcohol should be luxury. If I buy alcohol and it has a handwritten batch number on it, there should be an NFT. That is an NFT. The batch number is just not very secure. You know, I do that. I buy wines that have numbers on them and bottles of whiskey that have numbers handwritten on them. That should be scannable. You should be able to scan that. And we will get there. We're going to get there. Who's going to verify it? For me, I will verify the number. I'll go into the store. I'll literally pick up two bottles. I'll say, do they have different numbers? That's my verification. It's the same store selling a same batch with different serial numbers of whiskey. For these ones, if you sell a batch of 200, if none of those 200 people ever scan it, that is not so useful. So I'm saying importance. I'm not saying value. For drugs, it has to do not with the purchase price of the drug. It has to do what is the cost to the reputation if somebody dies. So I guess maybe we got a thesis here. The value of the validation technology that you're using is related to what are the odds that one person will ever scan one of the dots in a specific batch. Will anybody ever scan one of them? That's your value proposition.
Mm-hmm.
And if you can say no, then there's no need for these dots. We want to bring that ceiling down. We want to bring the price ceiling or value ceiling down to where there's more applications where we can use the dots. So when you're printing these, is the idea that when you send it to the customer, you're going to have a GIA report showing this is what they use for diamonds. So they got a picture of the diamond from the inside or whatever. Are you going to show them a digital copy with this? So if you gave the wine this sheet, or you gave the wine company this sheet, and you gave a different one to the other wine company, you still couldn't tell them apart because you never scanned them at the time of delivery. So in order for you to actually do this, you would need to scan them before you give them to the customer, right?
Yeah.
Okay.
With wineries, we printed a bunch of labels. It looked like, one second, like this.
Oh, yeah.
Right? We scanned them, we sent to them, and we already knew, ideally, if we're talking about large batches, we just integrate this production technology directly to the production site. So when they create bottles of wine, we create the labels, they print them directly, and then during the production, they have a camera, which is a quality camera that they still already have, and this camera it can takes pictures and go and sends it to the
Whoa.
database.
Okay, now we're getting excited. So you're saying during the production process, this is the original labels?
Whichever you like, because
Okay.
the production technology we use for our labels is compatible with glass, with plastics, with everything.
Yeah.
It's very traditional technology. It's not digital printing, but it's something that is used directly on producing stuff. Yeah, it's just dots. I wouldn't be able to patent this. It just mixing glitter with dots. But the value of the technology is in the ability to identify this and being able to identify them during the scanning process, right? So the idea is that in terms of our business model, when you print these labels, you take a pictures and register them in the database. That's where we get.
So now I want to bring in some other competitors. One of them obviously is Diamond Dust. They actually use this in defense and aeronautics industry today. So you're a direct competitor for that. So they blast it onto whatever, and then they use imaging, they high resolution imaging, and this technology is integrated into the engineering supply chain. That is high resolution scanning. Then I'll give you on the other end, when I go to NFT conferences, and what they'll do is they'll say, I've got a physically unique label that I applied to my product, and you can use your iPhone to scan it.
Yeah.
I've seen this exact thing, and they use the same trick every time, and I defeat it every time. If you do it in a dark room, my room's not dark enough, it will actually blast a grid of red dots
all right
onto whatever. What I'll do is I'll just cover the light, and it won't work. They're not actually reading the picture, they're just seeing if it's sensitive to that color wavelength of red light.
All right, yeah, okay.
Uses. But they're not doing anything that they claim. And they're like, oh my God, it's super high resolution printing. I'm like, everybody uses their iPhone to scan a QR code. So you know how close you got to be to the QR code to scan it. That's exactly how close you need to physically authenticate any 2D matrix. So obviously the iPhone will never scan your product. Obviously this will never scan this at a resolution that can distinguish these two things. So what level of camera do you need to get a useful distinguishability between these?
Can you take these labels? We have a live pilot with wine, and people scan this with their smartphone camera, just a smartphone, like a QR code. Yeah, so that's it.
Okay,
right?
So I did take a photo, so I zoomed in, so I've got the dots, and I can distinguish them. However, obviously, I could forge this. That's because, and it's very easy, if you just scan in, if you zoom in, I cannot see the individual dots of the P.
Oh, it's in Russian. It's родной.
So the first letter here of родной, I cannot see the dots when you printed it. Therefore, it is possible for you to make these dots indistinguishable because my iPhone can't zoom in enough to see the dots of 300 DPI or whatever DPI this is printed.
Yeah, of course. The idea is that you take an image, you get these dots. You can identify it, right? We're talking now about just unique identification. You can identify it easily, right? Like with the fingerprints. And then if we're talking about forge resistance, you are, I'm claiming that you can use the this kind of a dynamic reflection of these dots, not the ones that you have, but imagine that if you have the ones that are shiny one.
Yeah.
You can use these dynamic reflections as an additional proof that this was not just printed with a printer, right? That these are 3D particles randomly dispersed inside of the polish, right?
I've seen some pretty good printing, and these could just be, you can print silver.
When we're talking about like the glitter powder, right? So these dots, these ones I sent you, yeah, they're just gray and black, but you can use holographic ones, right? So the ones that are really shiny, that change the color appearance when tilting. And then imagine that these labels, so right now, the layer of polish is very thin.
Yep.
So as a result, you see that each particle, it's kind of lies on a flat surface.
Two-dimensional, yeah.
Yeah, imagine that they have three-dimensional distribution. And each particle, it has its unique angle, and as a result, unique reflection. Unique reflectance characteristics, right? You can use everything, a lot of these characteristics, to check that what's down there is actually 3D.
Okay, so now I got to run this back to you. the authenticity is only as good as the time that you scan it in production. So if it's coming through the production line, you're only doing one photo and it's moving. So unless you're scanning it 1, 2, 3, 4, which other people do, if you're not doing that in production, then that's not going to work.
There's different ways how we can do this. First one, yeah, you can take different images, right, during the production. Second one, you can say, hey, these labels, you can uniquely identify them, first of all, by comparing with the database. Second of all, you can look at this label as you probably will look at a hologram and check that this label is really 3D, right? So you do this by yourself, not with the scanning device, right? And this is how holograms work, right? In general, and this is basically how the whole banknote system works. For example, the euros, they have like 20 layers of protection with holograms, watermarks, whatever, and most of them are checked organoleptically, right, with just your bare eyes. Claim one is that the labels that we have, they're great for unique identification. And then on top of this, if we're talking about real counterfeit protection, there is a number of ways how we can check that this was not somehow bypassed with all of this mechanism that you described. The first one is you a very good first way is when you print this, you do multiple scans. Second way is you basically you delegate this to the person who will check this manually. Yeah, and that's it. Yeah, so of course, when the smartphone scan this, it's basically 2D. But when a person checks this, person can tell 2D with this is 3D.
Yeah.
Without any kind of software
Yeah.
improvements that can, of course, can be easily made.
Yeah.
But why, if you can do this yourself?
I like it. I like how there's different levels. There's different resolutions of scanning. I like that you can perhaps get to a point where somebody says, "Oh, I've forged it," but then that just goes to another level because you just scan it better. You get a better scanner. So you take the same thing, you get a cursory scan, you can get a better scan. I like that doesn't refer a diamond dust. You can't scan anything. This is not for end consumer.
Yeah, this idea of multi-level protection, it's, I guess, the best solution for everything. Like with banknotes, you can bring this to consumer products. Basically, just hypothetically, you combine these labels with diamond dust, right?
So here's the $100 bill, the US $100. You can actually take a toothpick and put it inside the dollar. It's inside and outside. It doesn't go through the back.
Yeah, exactly, right, with banknotes. And another thing is that if we're targeting to, in some applications, for example, in applications in luxury or whatever, basically replace QR codes, then at this point, we're a much better solution. Why? Because the level of protection is still better compared to the QR codes.
I love it. For me, I really just have to compare this to diamond dust. And what are going to be your next customers?
Is luxury.
Yeah.
Of course, the definition of luxury can scale, but it's some luxury that hates QR codes. It's a certain layer of luxury that really hates QR codes because QR codes are a commodity. We are, in turn, not a commodity in terms of we're really design flexible, right? So you can put these dots on top of everything. You can make this invisible for some applications, right? So you can just integrate this fully into the design of a product, or you can make it as a label, but is a label which will be very nicely integrated within the design of a product. That's the focus number one, because it just happens that I have a traction there. Traction in terms of interest, in terms of some discussions.